Hello and welcome to the Internet of Water Coalition webinar series. Today we have a presentation about Geoconnex, a geospatial index that will enable users to quickly and easily find water data by theme and location. Geoconnex is one of the key technological developments that will make an Internet of Water possible. And I'm Lillian Watson. I am a policy associate at the Nicholas Institute Water Policy Program, and I'll be your host for the webinar today. Before we get started, I just want to cover a couple of housekeeping items. So we're recording the webinar today, and this recording and the presentation slides will be available on our website after the webinar. So if you'd like to refer back to anything you heard during today's webinar, or if you want to share this webinar with friends or colleagues, you'll be able to find those materials at the internetofwater.org or on our YouTube channel. We'll also be taking questions throughout the webinar. If you have a question at any point, please drop it in the Q&A box, and I will read it out loud so our presenter can answer it. And if you have any technical issues with sound or your connection, you can put that in the chat and we will try to help you get that fixed. So now on to the main event. Today we have Kyle Onda. He's the Associate Director of the Internet of Water Initiative at the Lincoln Institute of Land Policy. Prior to joining the Lincoln Institute, Kyle was the data architect for the Internet of Water Startup project at Duke University. And Kyle's led the development of Geoconnex since its inception in collaboration with partners at the USGS. So I will go ahead and turn this over to Kyle. Here we go. You should be able to share now.
All righty. Thanks for that intro, Lily. All right, is my slide the correct one showing? Looks like it is to me. Okay, so thank you so much, everyone, for coming. I've given a lot of talks about Geoconnex. Maybe you've heard some of them. This is going to be kind of our first unveiling of some ways for the general public to interact with things that are inside Geoconnex and browse the wide world of water data out there. And that's really the main point, is to show off stuff that's in there and give you a little bit of a roadmap moving forward and give you guys an opportunity to ask questions and make suggestions, frankly. So the outline is I'll give a brief motivation and vision for the system and a brief overview of what the Geoconnex system is. I'm not going to delve really into the weeds of how it works because that's really about what data providers do. But I'll give a brief overview so you understand what's going on, and then go in through a bunch of demonstrations of other software out there and software we've developed that interacts with Geoconnex to address some water data challenges. All right, so the motivation, right, is, as many of you may know, it's difficult to comprehensively organize water data about something you're interested in. So here's the current Google search for stream flow near the town where I live in. And what we get is a mix of structured and unstructured data. It's dominated by USGS systems and statewide views generally when you look at stuff. And it's missing important topics and data providers. And we want to get to a place where even a commercial search engine like Google would be able to do something like this, where it's much more organized by topic, offering site level granularity out of the box without any required prior knowledge of which data providers might be around. And as we started the Internet of Water project, looking around, we sort of decided that a good way to do this would be an index. An index to help us search for information related to things we care about in different ways. But what is an index? In the old school, in books, right? An index is a list of items at the end that gives for each item the page number where it might be found. So we have a list of topics and then a way to go find the information on those topics. So if we're thinking about an internet of water, so what's an index in the context of the internet? One kind of facile thing to do would just be to change some words in the definition for the book, right? So it's a list of items treated in everything we know about, every website on the internet, that gives for each item, instead of page numbers, URLs where information about those topics can be found. And that's, and indexes like that are what undergird search engines, which let you find things. And it's why Apple Corporation search in Google gives you these different URLs to find out different things about Apple. All right, so what's the Geoconnex system? It's a set of core infrastructure and data publication tools and technical guidance for data providers to help the water data community build and use a water data index. Who is the Geoconnex system? I mean, it's ultimately been guided by the principles of the Internet of Water and the Internet of Water Coalition. It's funded by a grant through the Duke Nicholas Institute, as well as some WRI agreements with USGS. It's being developed by myself and other staff at the Center for Geospatial Solutions at Lincoln in collaboration with folks from USGS, although we at Lincoln and CGS operate the actual infrastructure, do most of the data management. And we have data being contributed so by a growing set of entities, USGS, EPA, California agencies, New Mexico agencies, non-governmental organizations, the Western States Water Council. I forgot to put Oak Ridge National Laboratory here. We're in discussions with the Bureau of Reclamation. And we want to keep adding more. All right, so how does Geoconnex get us to a water data index? What it is, it's a registry. Fundamentally, a big part of the system is this geoconnex.us, which you can plug into a URL and it will take you to a description. But it's a registry of persistent identifiers. So think like DOI for documents and data sets, or ORCID for people. You might be familiar with that. For two kinds of things. The first thing is what we're calling reference features. And so these are in our index, that list of topics or names, right? So the reference features are the general topics that we know data is about. And so why is it useful to have something like this? Think about a question or a query like, I want the current stream flow readings from all gauges on the Colorado River. If you look up the Colorado River, well, there's a few, and there's two in the US, two big ones in the US, the one in the Southwest and the one in Texas. Right? So, no laughter. So what Geoconnex offers is these unambiguous identifiers in the form of URLs for different things. So one such thing are the main stems of our big named rivers. And so instead of having this ambiguous Colorado River, we can have this identifier for our southwestern Colorado River, for the person who's interested in that. And if you were to go to this URL, you are actually taken to a website. You are redirected to a website that just represents this very river. Or you can be interested in the other Colorado River, which has a different identifier, and that's fine. We're the Texans out there. All right, so those are reference features. The other thing are organizational features, and this basically boils down to data sets that other organizations have published about items, increasingly items that we hope to be reference features. And we want these to also have URLs. We want you to be able to find them on the internet as well. And importantly, we want those to be kind of discoverable at the site level. Right? We want to not just find all the data on the Colorado River, but on particular sites we might be interested in the Colorado River. So this is an example where these are all of the reference features, so the reference locations on the Colorado River where we know data is. And if you were to go to this website, that would give you links to places where you can find data about that location. So including the USGS stream gauge location there, but there might also be a water quality monitoring station by a different agency. Okay, so that's the identifier registry, and there's other components of the Geoconnex system. The reference features are available in public for anyone who wants at reference.geoconnex.us. It offers an API to look up reference features, import them into desktop GIS or R or Python or whatever. And we also have packaged reference feature datasets available on HydroShare for download, and I can direct people to those later. Both reference features and the organizational features we know about are represented in a knowledge graph, so basically just a database, a graph database that tracks relationships between these URLs. So which URLs have information about other URIs. Which organizational features have information about which reference features. Which reference features are upstream or downstream of each other or on the same river. These kinds of relationships. And we have various, we're still going through the best ways to let the public interact with this. And we have a couple of first cut ways to do that. All right. So we just have some demonstration here on what you can do now. So the first is we can just browse, what's in the system. And so first I'll go to this web map who our new staff member, Emily Wiggins, made heroically. And it's a really good visualization of just what all's in the system. And again, if people want to go there, you can go to geoconnex.us/IOW/map. Don't all go at once, though. I don't want it to crash. The map is, it's a pretty standard web map. We show some jurisdictions, the states, the counties, Native American lands across the country. And as you zoom in further, more things start to show up. So we see our main stem rivers reference features coming in from our reference features API. We also see public water system boundaries, which has been a whole other project we've been involved in, helping to organize those around the country. So here we have the Santa Fe water system service area. And when you come down and look for features, you'll notice that most of them have a link with something called the Geoconnex identifier or ID. And there it is there. It's a URL formatted geoconnex.us/something. And that's the persistent ID that will take you to the website that's about that thing. I see we have a question. Oh, okay. That's just Lily saying there's a question. All right. And then we can zoom in further and more sites come up, right? There's tons of data out there that we've been organizing and getting into this system. There's an interactive legend that you can that you're free to play with on this site. So a big contributing data system is from WADE, from our friends at the Western States Water Council that are organizing water rights at points of diversion and points of use across the country. And so all these orange triangle are points of diversion, and they are linked to WADE's own data system, which will eventually provide water rights information. So about that point of diversion. So it looks like this one, we have the owner and they have a permit and for a domestic household beneficial use. So that's good there. And so you're free to sort of explore that. But we have stuff from states. So we have a separate California stream gauge catalog. We have everything that the New Mexico Water Data Initiative has organized and contributed to Geoconnex. So that's five or more agencies contributing data, and those sites are in pink. we have all of the named locations in the GNIS, the Geographic Name Information System, the surface and groundwater NWIS sites, all of the dams, all stream gauges from all organizations we know about. So these are the reference stream gauges. And so, yeah, you're just kind of free to explore. This can be helpful. I see there's another question. Do you mind sharing the URL to this IoW Geoconnex features app? Yeah, I'll do that. It's I could do that at the end. And then is there a connection with Energy Star Portfolio Manager? We have no direct connection with that, but we're happy to explore it if you have good points of contact for that. If that's one thing to know is this is sort of designed for publicly available information, so it can be more complicated to mask things where there's personally identifiable information involved. How often do you update this app and its data? So ideally, we want to get to a place where this app is just sort of continuously updated as soon as we get new data, and we don't have like a set schedule for when we import new data or anything. We're constantly looking for more data, putting it in, and we want to get to a place where this is just sort of up to date. Okay, I'll move this aside.
Kyle, there's one more question from California.
All right, will California be providing rights info through eRIMS? Good question. I think California will be setting up their eRIMS system, and we are happy to integrate that data directly with Geoconnex. I also believe they are providing that data to WADE, and therefore into WADE's standard cross-state data model. And so there might be both representations that you can find through this system when California does that. Okay, the next user interface, which is just at the very beginnings, is our free text search. So you can do things like just search for something like Sacramento River, Google-like, but less good. But you can free text search, and it's pretty rapid. See what happens when we pop in Denver. Lots of things about Denver. You'll see USGS has the lion's share of a lot of things when you put this in. But we're still tuning this. Do you or can you also include socioeconomic information such as population estimates? Yes, it is on my to-do list to add representations of census block groups and above for 2000, 2010, and 2020 geometries. Is there any coordination with search engines? I don't want to get into detail, but yes, the core of this system is asking data publishers to publish site-level information using JSON-LD structured metadata, including the schema.org vocabulary, as well as specialized water data vocabularies. New data providers, I'm being asked, as data providers bring new observation locations online, how do new sites get accommodated into the index, and is the process automated to find new sites to add to the index? So I don't want to get too much into that today, but if you go to geoconnex.us, just that URL, you'll find a page that describes the persistent identifier registry. And basically you add identifiers, it's open, it's free, and that tells us, and so you give us those identifiers and places to crawl, and places those identifiers point to on the internet, and we crawl them and ingest structured metadata. That is how that needs to be done. It's an ongoing effort to create lots of good documentation and do lots of outreach and direct technical assistance to help data providers do that. Okay. A little off track here. Okay, so that's the text-based. All right, we also have the API features endpoint, which people are free to go to here. So this is the sort of new standard WFS. And so we have all these collections for all of our reference features. So we have HUCs 2 through 10. We have the USGS defined national aquifers and secondary hydrogeologic regions. We have reference gauges, main stems. These are the census units I was talking about, and I do want to get those lower levels below counties in there so that we can link and pull in the census sociodemographic information. The public water systems and dams. So a good example is dams. This has its own query functionality. I don't want to get too much into it here, but I will just demonstrate how you can use this web service to pull our reference features directly into like a desktop GIS. So here's QGIS. You can do this in ArcGIS as well. If you add a WFS or ODC API features endpoint, you can create a new connection. And you just put in the URL reference.geoconnex.us. I pulled it in twice, but that's okay. And then you have access to all our collections. And so I'm just going to pull in the principal aquifers collection. And there it is. And it shows up. And you can use it in your desktop GIS and change the symbology and all of that good stuff. Here, I'll just change its symbology to rock name to show that you can do that on the fly, hopefully. Perhaps not, but you can pull it in and then from there sort of export it to your desktop to like a shapefile or GeoJSON file if you prefer. And again, this should work in ArcGIS Pro and Online or Enterprise as well. Are you working with FEMA to pull in firm information? No, we are not currently working with FEMA to pull in firm information. We believe that kind of information should be in here, but you know, that I'm taking this as a suggestion, a thing to put in our TAC board. Aha, yes, Andrew. Yeah, we have a Spark endpoint. I will get to that in a bit. All right, so the next sort of way to use the Geoconnex system, right, is to add, one way to add your stuff to the index is by tagging data you publish with the reference features. And so Kuwazi has implemented a system to do that. Kuwazi are our great partners at the, they're sort of the University Alliance for the Advancement of, or Universities.
Consortium of Universities for the Advancement of Hydrologic Science.
Incorporated, Kuwazi. All right, they have a system called HydroShare, which many of you know, to publish data. And when you share some data with HydroShare, you fill in all kinds of metadata like your title and abstract and keywords. And so very similar to keywords is we want you to be able to tag your data set with the geospatial features it's related to. So here I've uploaded a data set of some information that I hypothetically collected in this general metropolitan region. I might have some water quality samples. And here I've tagged it with related geospatial features. So if I edit this resource, I'll show you what that looks like. The people at Kuwazi did a great job with this. Is you can choose a reference feature collection to search. So I'll do maybe main stem rivers. All right, they're having some sort of issue. Perhaps maybe states is easier, right? So it shows the state. And then, so it shows you that the state kind of intersects my region, and I can click the state and add it to the list of features that I am tagging. Let's see if we can get the dams to work. Okay, so there's the dam. So these are all of the dams in the region, and I might be able to go down and say, yeah, I actually collected a water quality sample at this dam. So I will add it. And that's great. So then I can save that, hopefully. I think that's saved already. And yeah, and that should be tagged. And so for those of you who are like who are into search engine optimization or know this structured metadata, oops, semantic web sort of world, Kuwazi does a great job of, oh no. Well, it's embedding the structured metadata that includes, I'm not sure why this isn't working right now. I practiced. Here, let's try this. We'll just reload it from here, not in edit mode. That's probably what happened. Here we go. So in the source of the page, we have JSON LD embedded into the script header. And it says, and it's declaring that this is a data set, and it is about certain things, and it has the dams, all the dams I have identified, and the urban area and the state. And so that's what helps us build a knowledge graph over time when people are publishing websites like this that have structured metadata that are about common identifiers. Okay. Let me move to the chat for the question. Okay, that was Andrew's question. All right, so the last thing to do is, great, there's data sets that have been tagged with reference features or have their own GeoConnex identifiers. A great thing to do is to start to query systems. First, I'll stop. So I have a question that says, can you elaborate a bit on the relationship between Geoconnex and HydroShare? What makes them different? Yeah. So HydroShare is a specific metadata publication and data set sort of sharing and publication platform that's operated by Kuwazi. And you can, and it's great, and people can do that. Geoconnex is the system of identifiers, principally, that lets you, for things in HydroShare or any website, to declare themselves to be about, right? So Geoconnex is an index, and HydroShare is kind of a metadata catalog and data store. Geoconnex is an index that ultimately we hope would include many things in HydroShare, as well as many things that are published by public agencies through their own platforms, like the USGS or state stream gauges or water quality stations. Okay, so a good example of a use of a Geoconnex identifier by another system that's not HydroShare is the new USGS instantaneous values API. At this URL, you can find the R code. So t.ly/e big X 1 little x. Find some R code to which I'm going to just demonstrate right here. And again, I'm not going to belabor this point. Not everyone's learning R. I'm making this point about shared identifiers. So remember what I was saying about how identifiers are useful for disambiguating, human readable names. There's two different Colorado rivers. So here I'm reading in both the Colorado River, the big one, and the Colorado River that's mostly in Texas. And so you see, all I've done is I've pulled in those identifiers. I'm reading them as spatial features from our API, essentially. And from there, it's trivial to make a map of both. Here, I'm defining a function that I won't get too much into, but basically, the USGS API allows you to filter their monitoring location sites by the main stem URI, their Geoconnex identifiers. So the same ones here. So here I'm defining a function to ask for the latest discharge observation from all sites that are on a main stem that I give that function. There we go. Let's finish that up. Okay. And so here I want all of the Colorado River in the Southwest discharges. And here I am with the legend. So I see, you know, we're below like 100 CFS over here. And about here we're at 11,000. And then, you know, back down to 1,000 at the border with Mexico. And that's pulled in live. That was pulled in live. I can sort of see you. That's the measurement at 7 p.m. You know, universal time. Yes, can I share my R example? It's in a short link. The short link that I'll go back to on the slide links to a gist. Mark. And then we can do it again with the Colorado River in Texas and show both. So here's the short link to the R code. So t.ly/e big X1.
Kyle, there's a question about the relationship to or link to Wikidata.
Yeah, it is. We will be creating links to Wikidata, at least for the main stem rivers, and to the extent we can genus to do that. Unique integer identifiers are hard for humans to interpret and may lead to confusion. Has not been given to using a unique agency ID with location ID to create human readable unique. Okay, so I didn't want to get too much into this, but our contribution system essentially allows agencies to set up a namespace and then use any identification scheme that they want. So if I go back to the map here, a good example, I think, is Wade, right? So if I copy the persistent identifier for Wade, I copy the link address. Here we go. So the link address for Wade is geoconnex.us/Wade/sites/CA, you know, water right, you know. So it's still, and this is what Wade has decided to be their identifier scheme. So I'm not going to enforce something more human mutable on there, but basically that's how it works. But in terms of the reference features, we try to use, in most cases, we try to use existing established institutionally supported IDs. So, you know, good example for the census units would be their geo IDs and FIPS codes. But for some other things, we like to, it becomes hard because the idea with reference features is that many agencies have their own identifiers for a specific place. And rather than make one up, it's sort of just easier to generate integer identifiers that aren't dependent on any one system when there's a situation where there's no one authoritative list of the sites of things in that category. But the idea is, I'll show you in just a second here. So a good example, right? So even with the FIPS code, so the identifier for ref states 48 takes you to Texas, where then we have the name Texas. And the point is that we are harvesting a machine readable version of this website and then indexing that information. So in our free text search, you would be able to search Texas, and it would interpret that still. It'd be able to interpret things that are related to this identifier via that name. But I agree, it's a balance between wanting to keep things unambiguous and neutral in a place where there's multiple data providers, while also being interpretable and searchable. Let me check the time here. Okay, so then we have some emerging applications. So Andrew asked, is there a Sparkle endpoint? Yes, there's a Sparkle endpoint at graph.geoconnex.us. We're still building out all of the relationships, but we are free to do a Sparkle endpoint. And so here it is. And here I have a example query for a slightly more complex conceptual query. And what this does is it says, given a place, given an identifier, give me all of these stream gauges that are on the same river that this thing is on. So that's what that Sparkle query does. And so then, of course, it's possible to build other user interfaces on top of that Sparkle endpoint, which we've done here. So if I search for Sacramento River, here, it gives me a list of things that, by free text search look like the Sacramento River. But we've built in a backend to a Sparkle query to ask for the monitoring locations that are on the same main stem. So if I click here, it gives me those. And what's cool and gives us the knowledge graph is, yes, most of these sites are USGS gauges. But let's see, there's, yeah, so this site here is actually being contributed by the California Department of Water Resources, right? So we've harvested both USGS and California data, and so they are both discoverable now. So this, come on, California. Yeah, there we go. So we have this California stream gauge that's on the same river as the first stream gauge that we looked up. You can also manifest this in a more visual map type interface. And we've done so here. Emily's done so. So we can go to, can zoom into a place here. Oh, this is the one that might take a while, but let's see. Here we go, Golden State. Right, so on the North Fork of the American River, I can ask for related gauge locations, and it will spin up a bit to, actually, it might be here already. Yeah, it's here already. So I did this at the Sacramento River, right? So I've been able to search for all the gauges that are on the same river across different organizations. So the blue are all historical USGS monitoring locations, and the orange are sites coming from the California Department of Water Resources, but they're all on the same river. And so that's from the Sparkle query. Is there a roadmap to extend outside the USA? There is no current direct roadmap, although we have applied the principles of persistent identification of main stem rivers to the globe. If you want to look at, let's see, I think it's called River Runner Global. I think we did this in collaboration with Sam Lerner. I think this, that's something we've done at a global scale, and I would say we're interested in opportunities to apply this at a global scale, but currently we are focused really on the US. That's why it's geoconnex.us. Adel, yes, this is on our own enterprise Esri server, that web map. But the reference features are coming from a different open source server that we operate, and it's just streaming that service. So that is a good example of the utility of open standard APIs. Okay. So our next steps are we want to add more reference features collections. So we want to do things like try and organize all the aquatic barriers and the culverts and the wells and the levees. And we know the Army Corps already does a lot of work on the levees. The public land survey system as an additional spatial reference. We'd like to get more sources in there, like Reclamation's RISE we're in discussions with now. So the Reclamation sort of information sharing environment. Get a representation of the EPA waters database and any state database that wants to work with us. And we also want to really improve this querying and filtering and other user interfaces. We think people will want to be able to filter sites by organization and the parameters the data are about, and maybe their period of record and perhaps data quality, although that can be harder to organize. And so with that, I'll end and open it up for more questions.
You've got another one in there already. Can you give a little more detail about harvesting, specifically interoperability with existing harvester frameworks like CCAN?
Right, so a lot the CCAN and like Socrata, they're kind of federated metadata harvesting are really based on data sets. Whereas what we're trying to do is index site level information. So we need every site to have an identifier. And by site, I don't mean website necessarily. I mean like the physical location that it's on. And so to the extent that CCAN, I know CCAN's open source. So, typically the way I've seen stream gauge information, right, shared in CCAN is there's a resource, which is a table of all the stream gauges. And so it's difficult to fit that in our framework without some sort of other level that would go deeper into the table to be able to represent a JSON LD graph of every row in that table. But we do, right. But we do have an OGC API provider. Sorry, my developer, Ben Webb, just reminded me of this on Slack, that we do have a way using an open source Python server called PyJu API, which I'll pipe here, which has an extension that enables it to specify an API endpoint for a data set that's in the CCAN data store and let you configure sort of how to take rows from data sets in CCAN and publish individual web pages in a dynamic programmatic way that is harvestable by the Geoconnex system. All right, how do time series fit into this? Is Geoconnex focusing on spatial and then go to the original provider for a time series? More or less, yes. What we would like to happen is for people publishing time series data that are about spatial locations to publish metadata that includes specific references to where the time series data can be found. And to do that in a structured way so it's interpreted by machines. So it would be something like, I am this site, I have data on discharge at this time interval available from this API call. And it's focused and it's formatted like this with a reference to this API conformance class. Are you focused on surface water data or are you including groundwater? If groundwater does include both tributary, non-tributary groundwater. We are including groundwater data. And yes, there's a lot of active work with our collaborators at USGS on this, and I can't say anything more concrete about that right now. Is versioning handled? Our first foray into versioning will be with the census, and we're going to set up a new identifier scheme that essentially incorporates versioning. Are you planning to include ecosystem or watershed information? Yes, to the extent that we can find it. and people are willing to work with us and understand their data models so that we can express it appropriately. We're not doing much of that like right now, other than the way that EPA represents it in like its waters database. But yes, I would say that is something we want to do.
Great. Could you also tell people if they are data producers where they can go to learn more about how they would get their data into Geoconnex?
Yes, we have some documentation for this at docs.geoconnex.us. That page is still under construction, but that's where I try to get a lot of our things out, and I do need to update that more. But that's a good first point of reference before reaching out to me directly.
Great. Well, I guess we'll give people a minute to add any other questions, but I think that was really comprehensive. Thank you so much, Kyle, for going through everything. And I just want to let anyone on the call know that if they want to find out about more of our webinars or anything else going on with the IoW Coalition, they should join our mailing list, which I just put in a link to in the chat. You can also follow us on Twitter at Internet of H2O. And you can, as I said at the beginning, find videos of all of our webinars, including this one, at our YouTube channel, which you can find just by searching for Internet of Water Coalition. Looks like we're getting some more questions. Any plans for climate change data?
I don't know if we have imminent plans, but we acknowledge that such a system that we're building would be applicable to things other than just water data. So I think we're open to that. We don't have any sort of funding directed to that. Are there plans to link hydraulic and groundwater flow models as well as flood inundation products to the location indexes? I think perhaps we actually do have active proposals in to do things like this, but until we can fund that, so it's a little more complex. I can't say anymore. Will link to recording be emailed out? I'll ask Lily.
Oh. We don't typically email the links out to all the participants, but we do post on Twitter whenever our videos go live, and you can also find them just on the Internet of Water website. Generally, the videos are posted within about a week of the webinar.
Kyle, as we get to the end, I wonder if you can sort of make a high-level statement and draw a line from the development of the Geoconnex system and the data that it offers through to tool developers, through to, say, a decision support system, through to, say, a policymaker or a farmer. Just draw a line to the widest possible user for us.
Right. So the basic idea, right, is a policymaker wants an answer to some sort of question. And they might want an information product to be able to do that. And in our digital world, information products can be very usefully made with specialized software, decision support tools that make use of data that comes from many sources that needs to be integrated. And the more discoverable, accessible, and interoperable that data is, the easier it is for software developers to make such tools and to uncover data that might be available. And that's where sort of Geoconnex operates, is it's a way for data producers to make their data as discoverable and well described as possible, so that tool developers can kind of make use of that information and decide whether and how to use that in tools they're developing.
Thanks, great answer.
Is the NLDI part of Geoconnex? That is what the NLDI, for those who don't know, the NLDI is an API that USGS operates that lets you take a point and search for points from any indexed data source upstream or downstream of that point. So you could ask a question like, I would like all USGS stream gauges and California operated stream gauges upstream, including tributaries 50 kilometers at this point. And what I view that as is Geoconnex is a very broad, large graph of relationships between observation locations and things like stream reaches. The NLDI is based on a more relational database. So it takes data, or it's a representation of data and metadata that's in Geoconnex, but it's built into a very much more highly performant, specific querying mechanism. And so that's the kind of thing we want to happen. If we're successful, Geoconnex will be a way to support lots of things like the NLDI.
And you've got another one here. Is there any plan for a pub/sub method of accessing water data? Users can subscribe to specific parameters for specific sites and get updates of changes in real time.
Right. So the Geoconnex system isn't designed to, ingest observation data. Like we don't want our graph to include like the 15-minute interval data coming off of sensors. But other systems are designed to do that. So the USGS sensor things API endpoint does offer pub/sub through Mosquito or MQTT. Our developer is working on another. We contribute in kind to another system that the WMO is building called WIS2 box, which sort of is designed specifically to do that. But that's we want to index the station metadata coming out of such systems into Geoconnex to allow people to then decide whether they want to subscribe to those endpoints. But we're not going to offer pub/sub on our metadata specifically.
Yeah, if I could just add to that, Geoconnex is a system of data discovery rather than access per se. It's designed to bring you, but through a machine or through your own human intervention to a place where you can access it. But we are also building other tools for access, as Kyle just described.
So Nathan asks, are only active sites included with Geoconnex queries? This is a big point. Right now, we don't have a way to filter by active, inactive, or period of record. That is on the roadmap, though. Right now, just everything is in there, whether it's active or inactive.
Okay. Well, oh, no, that's just a thank you. Is there a public roadmap? There's one more question.
There should be. That we should definitely make one, but there isn't like an easy roadmap that you can go read right now.
Okay, I guess I'll give 1 minute here for any last questions from the audience. And thank you again to Kyle. Here's another one.
Are there methods to crowdsource data? Thank you for the kind words, Carolyn and Devin and Stacy. And Andrew asks, are there methods to crowdsource data quality so producers and consumers have a bidirectional dialogue of source? Not that I'm working on. I'm open to suggestions about that.
Okay, now I think we're done with questions and we're about out of time here. Unless anyone slips one in at the last minute, you can feel free to. But again, thank you, Kyle. This was really great. I think you covered a lot of really good information in a short period of time. And thank you to everyone who asked such valuable questions throughout. I think that really helped everyone get a good understanding. And thank you to Peter for joining as well. Peter's the director. I don't think I introduced him, of the Internet of Water initiative at the Lincoln Institute of Land Policy. So thank you, Peter, for joining us today as well.
Sure.
And with that, I think we will sign off here. Goodbye.